Hello and welcome back. For this example, we're going to be taking this implicitly defined function, x cubed minus y cubed equals 1. We're going to find the derivative using implicit differentiation and then use the result to find the equation for the tangent line when x is equal to 1. So again, it's not required. However, I find it extremely valuable to rewrite this using our function notation. So this is going to be x cubed minus the function y of x cubed is equal to 1. And now we're going to differentiate both sides with respect to the independent variable x. So again, we're taking dx of both sides. So the derivative of x cubed is just 3x squared. That's our typical derivative of a power rule application. Now for the next derivative, that minus of course carries over, and the derivative of the outside function is 3 times y of x squared multiplied by the derivative of the inside, which is y prime of x. You could also write that as dy dx, but I like using the prime notation. And then on the right-hand side, the derivative of the constant 1 is just 0. We can now isolate, and we can also suppress our notation. So by suppressing notation, I mean we can just rewrite the of x's and just write them as the variables y and y prime. So this is 3x squared minus 3y squared y prime is equal to 0. And we can now algebraically isolate y prime. We can first subtract 3x squared from both sides. And then we can divide both sides by our negative 3y squared. And we have our derivative. So again, y prime, or again, dy dx, depending on your preferences, is going to be equal to positive x squared over y squared. And that right there is our dy dx, our derivative. But we're not done because we wanted to actually find the equation for the tangent line. So again, we want the tangent line when x is equal to 1. And we need to make sure we have a point when we're trying to find an equation for a line rather than just one coordinate. So we can go back to the original equation, substitute in 1. If we have 1 cubed minus y cubed is equal to 1, that tells us that we're going to have 1 minus y cubed equaling 1, so y cubed is 0, which implies that y must be 0 at this location. So we're looking at the point 1, 0. Well, that should be a big red flag for us because if you look at this formula, there is no way you could substitute this ordered pair into that derivative formula. So that indicates that we're going to have ourselves a vertical tangent line. So with a vertical tangent line, we're going to have a very simple equation for our tangent line. It's going to just be x is equal to 1 because it has an infinite or undefined slope because it's a vertical tangent line. And that's it for this problem.